Hi everyone, my name is Clarice Kate Pagayan, and today I'll be discussing with you guys some of the key topics we covered in engineering mathematics. Let's get started. We'll be focusing on three main areas. In analytic geometry, we'll explore the parabola, hyperbola, and ellipse. Then we'll move on to trigonometry, where we'll cover the right triangles, angle of elevation and depression, and methods for solving triangles. Finally, we'll delve into solid mensurations, specifically focusing on oblique triangles, volume, and the surface area. In analytic geometry is all about using coordinates and equations to understand shapes and their properties. So let's start with parabola. A parabola is a U-shaped curve formed by all points equidistant from a fixed point, focus, and a fixed line directrix. We'll explore how to find their equations and key features. These slides shows you the different orientations a parabola can have on coordinate plane and the standard equations that go with each orientation. On the top right, it has the x squared is equals to 4ay. This parabola opens upwards. Then we have here the bottom right. It is x squared is equals to negative 4ay. This parabola opens downward. On the top left, we have the y squared is equals to 4ax. This parabola opens to the right. Lastly, on the bottom left, we have here the y squared is equals to negative 4ax. This parabola opens to the left. Okay, so let's take a look at problem number 1 and try to solve them. The equation of parabola is y squared is equals to negative 12x. This is a parabola that opens horizontally to the left because the negative sign indicates it opened to the left. H and k is our vertex. We have h is equals to 0 and 0. Therefore, the vertex is at 0, 0. 4a is equivalent to the length of the latus rectum. Therefore, 4a is equals to 12. This is our total length of LR. And then a is equals to 12. Then 4 is we will going to divide to the 12. So a is equals to 12 divided by 4. A is equals to 3. A is equals to 3 stands for our focus. Now, we will going to find our latus rectum. 4a is divided by 2 is equals to 2a. So 3 times 2, a is equals to 6. That is our LR. Alright, so we've determined the length of the latus rectum, focus, and the vertex. Now we can use this information to plot our parabola. First, we need to plot the focus. We know the focus is at 3, 0, so let's mark that on our graph. Next, we'll use the latus rectum to guide us. We know its total length is 12 and it's symmetrical about the focus. This means we need to plot points 6 units above and 6 units below the focus. So, from our focus at 3, 0, negative 3, 0, we'll go 6 units up and 6 units down and mark those endpoints. Finally, we can sketch the parabola. We'll draw a smooth curve that passes through the vertex and endpoints of the latus rectum. Remember, the parabola is symmetrical, so make sure both sides are evenly curved. And there we have it. We've successfully plotted our parabola. Now, let's move on with hyperbola. A hyperbola is a set of points in a plane whose distances from two fixed points called its foci, plural of focus. How say different that is constant? Hyperbolas can either open to the left or right, up and down. This slide shows the formula of hyperbola. Let's take a look at problem number 2 and try to solve them. To analyze the given hyperbola equation, 25x squared minus 16y squared is equals to 400. Step 1. Divide the equation by 400. Dividing the equation by 400 ensures that the right-hand side equals to 1, which is a standard form for hyperbola equations. Step 2. Rewrite the equation after dividing. The equation becomes x squared over 16 minus y squared over 25 is equals to 1. Step 3. Identify the center since the center is not explicitly given, so the origin will be at 0, 0. Step 4. Identify the transverse and conjugate axis. Transverse axis OX is equals to a squared equals to 16, so a is equals to 4 because the square root of 16 is equals to 4. Conjugate axis OY is equals to b squared is equals to 25, so b is equals to 5 because square root of 25 is equals to 5. Step 5. Calculate the focus, eccentricity, latus rectum, directrices, and asymptotes. To calculate, just input using the given formula. And now, we will be able to plot our hyperbola. On the right side, I'll just simply label all the points. And there we have it. Let's move on with ellipse. An ellipse is a curve formed by all points where the sum of the distances to two fixed points foci is constant. These slides shows the formula of ellipse. Let's take a look at problem number 3 and solve them. To graph the given ellipse, step 1. Identify the center of the ellipse given as x and y. Since the center is not explicitly given, the origin will be at 0, 0. Step 2. Identify the major and minor axis. Major axis is equals to a squared equals to 25, a is equals to 5, because the square root of 25 is equals to 5. Minor axis b squared is equals to 16, p is equals to 4, because the square root of 16 is equals to 4. Step 3. Calculate the foci, eccentricity, directrix, and OR. To calculate, just input using the given formula. With all the necessary information, you can now be able to plot the ellipse. Now, we are done with analytic geometry. Let's tackle our next topic, trigonometry. Trigonometry is all about triangles. So, let's start with trigonometry right triangle. A right triangle has one 90-degree angle. Trigonometry uses the ratios of its sides, the opposite, adjacent, hypotenuse to find angles and side lengths. Let's take a look at problem number 4 and try to solve them. The angle of elevation from a point 116 from the base of the Eiffel Tower to the top of the tower is 67 degrees. Find the approximate height of the tower. First, we can illustrate the problem for better visualization. As you can see, the given values are adjacent side and the angle which are 67 degrees and 116 respectively. The unknown value is opposite side from the given angle. So, based from SOHCAHTOA, we should use the tangent or tan since it stands for opposite over adjacent. With that, we can just input the values and calculate for the approximate height of the tower by isolating the variable x. Just multiply both sides of the equation by 116 to cancel it out from the right side. Then, there you have it. X is equals to tan 67 degree multiplied by 116. You can now get your answer. The height of the Eiffel Tower is approximately 273 feet. The angle of elevation is the angle between a horizontal line and a line to sight to an object above the line. The angle of depression is the angle between a horizontal line and a line of a sight to an object below the line. Let's take a look at problem number 5 and solve them. Trigonometry angle of elevation. Step 1. First, we can illustrate the problem for a better visualization. As you can see, the given values are adjacent side and the angle which are 64.3 degree and 115 respectively. The anode value is opposite side from the given angle. So, based from SOHCAHTOA, we should use the tangent or tan since it stands for opposite over adjacent. With that, we can just input the values and calculate for the approximate height of the tree by isolating the variable x. Just multiply both sides of the equation by 115 to cancel it out from the right side. Then, there you have it. X is equals to tan 64.3 degree multiplied by 115. Then you can now get the answer of the x. Trigonometry solving triangles. Sine is equal to the measures of the opposite leg over the length of the hypotenuse. Cosine is equal to the length of adjacent leg over the length of hypotenuse. Let's take a look at problem number 6 and try to solve them. A given oblique triangle has these following sides. A is equals to 125.36, B is equals to 176.43, C is equals to 101.23. In this given problem, 3 sides were given, so we will use the cosine rule or formula. Then, we can just input the given values to the formula to get each angle. Now, we are done with trigonometry. Let's delve into solid mensuration. An oblique triangle is a triangle with no right angles. It may have 3 acute angles or 1 obtuse and 2 acute angles. To find the area of an oblique triangle, there are 2 measurements that must be known, the base and the height of the triangle. The base can be any of the side of the triangle. These slides shows the Heron's formula that part of oblique triangles. Let's take a look at problem number 7 and try to solve them. Solid mensuration, oblique triangles. In this given problem, we will going to use the Heron's formula. Then, we can just input the given values to the formula to get each angle. Volume. The volume of a solid is the amount of space it occupies.
Let's take a look at problem number 8 and try to solve them.
Solid mensuration volume. What is the length of a rectangular box if its volume is equals to 2,240 inches cubed, 5 inches as its height, and 16 inches as its width? So this problem needs some manipulation with the formula. Our given now is the volume of a rectangular prism, which is 2,240 inches cubed, its height, which is 5 inches, and width of 16 inches. So, since we are dealing with the volume of a rectangular prism, we will use the formula of volume of rectangular prism is equals to Lxw xh. And what's our unknown value based on the given? It's the length. So, how will we get that? First, let's just substitute the given values to the formula. Then, we will isolate the variable I, or our length, by dividing both sides of the equation by the quantity of the height multiplied by the width. So, the length of the rectangular prism is equals to 2,240 inches cubed divided by 5 inches times 16 inches will be 28 inches. Surface area. A solid object is a measure of the total area that the surface of the object occupies.
Let's take a look at problem number 9 and try to solve them.
Solid mensuration surface area. A specific basketball has a radius of 5 inches. Calculate its surface area using the correct equation. This is obviously different from our first example and simpler. First, identify what is the given. Here, we have our value of radius, which is 5 inches. And next, what is the unknown or asked value? The surface area of the basketball, right? So that means that it refers to a sphere. So, we will use the formula for the surface area of a sphere, which is SA of sphere is equals to 4 pi r squared. Then, just input the value of our radius and there you go, you'll get your answer, which is 314.16 inches squared.
Thank you for your time. I hope this presentation has provided you with a clearer understanding in engineering mathematics.